All right. I should be audible. I should be visible. Yeah, please let me know if I am. Good morning, good morning, good morning. Happy Navratri to everybody who's celebrating. Is it Navratri? Has Navratri started? Okay. All right, wonderful. Good morning. I'm able to see myself. That means all of you can see me too, hopefully. Yeah? Chalo, theek hai. Okay, great. Good morning, good morning, good morning. Happy Monday to everybody. Very, very happy to see you all. I'm Hafsa Malik and today I'm going to teach you color perception. आज हम सीखेंगे color perception के बारे में. We will actually understand not only the theories but also why the theories were proposed, who proposed them, in what year, and so on. ठीक है? Chalo, happy Navratri to everybody who is celebrating and happy Monday. Good morning. This is the start of a new week. और ये सितंबर का last week है. That means we've got a lot to do. It's going to be a very productive week and we're also going to relax a little after this week. All right. Okay, chaliye, let's get started. All right. So what about color perception? I'm going to help you understand. तो ये टॉपिक जो है ये बिल्कुल CUET 11th 12th ग्रेड से साइकोलॉजी के बिल्कुल UPSC तक ये टॉपिक काफी इंपॉर्टेंट है, राइट? सो फॉर वॉट एवर एग्जाम, आप जो भी एग्जाम साइकोलॉजी में लिख रहे हैं ये टॉपिक आपको कंपलसरी स्टडी करना है और इन डेप्थ स्टडी करना है. सो आई एम गोइंग टू ट्राई टू एक्सप्लेन प्रॉपर्टीज ऑफ कलर एंड ऑल ऑफ दैट फॉर यू. लेट्स गो अहेड. Happy belated birthday. It was Harshika's birthday yesterday. Happy birthday, Harshika. Ma'am, yesterday was my birthday. Huh? Happy birthday. Chalo, theek hai. Great. Wonderful. Now this is a little bit about me. This is also me. Not 3 but 4.5 now. Yeah, so that's that. Chalo, theek hai. Now how do we see color? Is it just that color exists out in our environment and it's simply projected onto our eyes and we're like, oh my god, yeah, I see color. क्या इतना सिंपल है? क्या कलर सिंपली दुनिया में एग्जिस्ट करते हैं और वो हमारी आंखों पे प्रोजेक्ट होते हैं और जैसे ही वो एग्जिस्ट करते हैं वैसे ही वो प्रोजेक्ट होते हैं हमारी आंखों पे और सिंपली वो इंफॉर्मेशन हम लेके जाते हैं ब्रेन पे. इज इट लाइक दैट? नहीं यार, it's not like that. Sensation is never equal to perception. We need to understand the basic tenet of perception. Sensation perception नहीं होता है. कभी कभी कलर कोई और होता है लेकिन उसकी परसेप्शन वो होती है जो हमारी आईज रिफ्लेक्ट करती हैं या जो हमारे फोटो रिसेप्टर्स रिफ्लेक्ट करते हैं. ठीक है? ओके, सो आई विल हेल्प यू अंडरस्टैंड एंड इट इज नॉट ऑल वेवलेंथ्स दैट वी आर एबल टू सी. मतलब हर वेवलेंथ या हर लाइट रे को हम कन्वर्ट नहीं कर पाते हैं कलर में. देयर इज अ सर्टेन वेवलेंथ व्हिच इज नोन एज द विजिबल स्पेक्ट्रम. ठीक है? ये विजिबल स्पेक्ट्रम जो होता है ये आपके लाइट्स के वेवलेंथ्स वो हैं जो आपको दिखाई देते हैं, जो हमारी आंखें या जो हमारा दिमाग मीनिंगफुली परसीव या मीनिंगफुली ब्रेक डाउन कर सकता है. ठीक है? तो आई विल गो अहेड एंड रिपीट दिस इन इंग्लिश एज वेल. The visible spectrum is a range of light wavelengths. Okay, these are simply light rays or light wavelengths. We say wavelengths in order to make more sense of them. These wavelengths are measured in nanometers. Okay, all right, nm nanometers. And जो हमें दिखाई देता है, the one that we can perceive, the one that we can actually interpret as color is known as the visible spectrum. All right. Now, where to where does it range from? It ranges from 380 nanometers or 360 nanometers also sometimes books will say. That's completely fine. To around 760 to 780 nanometers. ठीक है? तो इसके ऊपर और इसके नीचे क्या है फिर? इसके ऊपर मतलब much greater than this 800 and above are the infrared rays. इसके ऊपर जो हमें दिखाई नहीं देता और जो हम मीनिंगफुली परसीव नहीं कर सकते वो है आपकी इंफ्रारेड रेज, जो वेवलेंथ में काफी जो हमें दिखाई देता है विजिबल स्पेक्ट्रम से काफी बड़ी होती हैं और ये हम देख नहीं पाते हैं. ठीक है? ओके, ऑल राइट. बियॉन्ड रेड, इंफ्रारेड, बस इतना ही आपको ऐसे आप परसीव या ऐसे आप मीनिंगफुली रिमेंबर कर सकते हैं. और what about waves that are too short for us to actually visibly be able to notice or for us to meaningfully perceive? देखिए, जो वेवलेंथ अब 380 से भी कम है तो उनका क्या करते हैं हम, वो भी हम विजुअली परसीव मतलब उनको हम कलर में ट्रांसफॉर्म नहीं कर पाते हैं, उनको हम देख नहीं पाते हैं, इनको कहते हैं अल्ट्रा वायलेट, एक्सट्रीमली वायलेट, बिलो पर्पल। क्या है आपके पास? ये कलर्स हम कैसे परसीव करते हैं? यू रिमेम्बर विबजियोर, बचपन में पढ़ते थे, वायलेट, इंडिगो, ब्लू, ग्रीन, येलो, ऑरेंज एंड रेड, है ना? तो अल्ट्रा वायलेट, वायलेट से नीचे, दैट्स ऑल. Okay, the next time somebody asks you this, you should fluently be able to go ahead and explain to them. चलो ठीक है. Now remember also the VIBGYOR. Is it an increasing wavelength? क्या हम कह सकते हैं कि violet कलर की सबसे कम wavelength है और जो सबसे ज्यादा wavelength है वो red की है? Can I say that violet has the smallest wavelength and red color has the largest wavelength? Can I say that? It is very, very clear here. It is very, very clear here actually. And then you know what? There are cones in our retina. आपको पता है कि हमारे रेटिना में दो तरह के विजुअल photoreceptors होते हैं. This is your human eye and let us say bad drawing, but okay, you understand. I'll draw it again. All right. Okay, this is your eye, let's say. And this whole area is your retina. रेटिना पे दो तरह के फोटोरिसेप्टर्स मोस्टली होते हैं. One is your cone cells and another is your rod cells. Near the fovea you only have cone cells और आपकी cone cells यहाँ पे काफी concentrated होती हैं. उसके बाद आई आपकी rod cells, है ना? Rod cells are basically distributed across the periphery. जो आपके cones के ends होते हैं वहां, सॉरी cones के नहीं, रेटिना के जो ends होते हैं वहां पे आपके rod cells distributed होती हैं. Now rods are responsible for achromatic vision, मतलब colorless vision, मतलब black and white vision. तो क्या फिर color perception में हमें rods ही help करेंगे? Are rods the ones that are helping us for color perception then? Color perception is not related to rod cells. Color perception rod cells से related नहीं है. यहाँ पे क्या है सबसे ज्यादा related? आपकी cone cells हैं. Cone cells तीन तरह की होती हैं. There are three types of cone cells. You have the small wavelength cone cells, you have the medium wavelength cone cells, and you have the large wavelength cone cells. ठीक है? अब small wavelength कौन सी होंगी? Small wavelength is till your blue, violet, indigo, blue. Okay? So blue refers to your small wavelength cones. Alright, please remember this is very very important. ये सबसे important information है. अगर आपको ये समझ आता है तो आपके लिए जो कलर की थ्योरीज हैं वो काफी इजी हो जाएंगी. लेकिन अगर आप ये नहीं समझ पाते हो तो आपको वो भी समझ नहीं आएगा. ऑल राइट, ओके, वंडरफुल. जो ग्रीन है अब अराउंड 500 है, 500 नैनोमीटर्स पे ग्रीन कलर आता है, तो ये आपकी मीडियम वेवलेंथ है. ओके, द ग्रीन कलर एक्चुअली इज टेकन अप बाय और इज परसीव्ड बाय एंड इज मीनिंगफुली इंटरप्रेटेड बाय द मीडियम वेवलेंथ. Because we know that the photoreceptors are the ones that are responsible for transducing. ये जो लाइट वेवलेंथ्स हैं ये हम लाइट वेवलेंथ के तरह अंदर नहीं लेते या हम एज लाइट वेवलेंथ अंदर नहीं लेते. ये we convert this physical energy, light physical energy है ना, इस physical energy को हम convert करते हैं into electrochemical energy and we send it across from one neuron to another as signals that are action potentials and neurotransmissions. Action potentials which are electrical in nature, neurotransmissions which are chemical in nature. ठीक है? Okay, absolutely. Wonderful. So now what have we learned so far? We have small, medium, large wavelength cones. What is the large wavelength cone going to be? यहाँ पे सबसे बड़ी wavelength कौन सी है? सबसे बड़ी wavelength आपकी red color की है ना? तो वो कौन सा cone understand करेगा? वो आपका L या large wavelength cone understand करेगा. Three types of cones refer to three types of primary colors. This will make theories of color much easier for you to understand later. And what do I have over here? Since I am transducing energy, ये जो transduction हो रहा है, ये कौन कर रहा है? The transduction itself is actually being done by the photoreceptors themselves. That means, what does that mean? That actually means that it is either your cone cells or your rod cells in general that transduce light. तो यहाँ पे कौन करता है? यहाँ पे आपके कोन्स ट्रांसड्यूस करेंगे। किस तरह की एनर्जी? लाइट एनर्जी। कौन से वेवलेंथ? 380 नैनोमीटर्स टू 760 टू 780 नैनोमीटर्स। यहाँ पे स्मॉल वेवलेंथ कौन कौन सा है? ब्लू होगा। मीडियम वेवलेंथ कौन कौन सा है? ग्रीन होगा। और लार्ज वेवलेंथ आपका रेड होगा। ओके, ऑल राइट, वंडरफुल, वेरी वेरी गुड, वेरी वेरी। All right. Once you've understood this, please let me know if you've understood this. Then we are good to go. Let me know if there are any doubts. Also, please let me know. I will wait. I'll wait. Let me know if there are any doubts. If you guys have understood, that is amazing. Understood, ma'am. Clear, ma'am. Okay, ma'am. All right. Okay, let's go. Now let's talk about the properties of color. इसमें बहुत सारे बच्चे काफी confused होते हैं. So let me give you an overview today. What is hue, what is saturation, and what is brightness. Okay, a lot of us struggle to understand. In fact, 11वीं से ही बच्चे इसमें काफी struggle करते हैं because this is one of the important topics of 11th, 12th grade also. Right? Okay. Now, our experience of color. See, this is us taking in information. Now, we do not understand information as wavelength, but we understand it in terms of these three properties. हम जो कलर अंडरस्टैंड करते हैं हम इन तीन प्रॉपर्टीज में उसको ब्रेक डाउन करके ये जो वेवलेंथ्स होती हैं उनको इलेक्ट्रोकेमिकल एनर्जी में कन्वर्ट करके और फिर उस इंफॉर्मेशन को ब्रेक डाउन करके इन तीन प्रॉपर्टीज में अंडरस्टैंड करते हैं। क्या पहला है आपका ह्यू। ह्यू इज समटाइम्स आल्सो रेफर्ड टू एज द टिंट और सिंपली द कलर। ठीक है, सी इफ इट इज ओवर हियर और इफ इट इज ओवर हियर इट हैज अ रेडिश ह्यू, कैन आई से? And if it is over here, the hue is pink. मतलब overall आपका जो color है वो क्या है? It is simply the name of the color. Whether light or dark or bright or dull, I do not care. It is simply what color do I see. तो अगर आपको ये पूछेंगे name the color, तो आप क्या बोलेंगे? वो color का hue है. Okay? You simply name the color and that is the hue. Doesn't matter if it's light, doesn't matter if it's dark, doesn't matter if it's bright or dull. Now, is black or white going to have particularly any hue? क्या hue black or white colors के लिए important रहेगा? Achromatic colors that are perceived even by rod cells. Hue is not important for black or white, it is important for all of the other colors. Okay, all right, wonderful. ठीक है, great. Okay. Then saturation is a psychological attribute. Saturation actually refers to the purity of color. ये देखो आप, this is only where pigment is present. Do you remember when you actually paint or if you used to paint as a child? अगर आपको याद है कि आप बचपन में पेंट करते थे और पेंट जब आप लेते थे वो पूरा concentrated color होता था ना? When you take the paint out of the tube or the small tub, it is a pure color. दैट इज सैचुरेशन। लेकिन जब आप उसको ब्लैक के साथ मिक्स करते हैं, व्हाइट के साथ मिक्स करते हैं, वो लाइटर या डार्कर हो जाता है, राइट? इट चेंजेस इट्स कलर अ लिटिल बिट. It doesn't remain the pure color anymore, but it actually gets a little either darker or it gets a lot lighter. That is nothing but saturation. The purity of the color, the actual pigment. Pigment की concentration कितनी है? Color कितना pure है? That's all. Okay. All right. ठीक है. As we mix, the saturation is going to decrease as well. Lastly, what is brightness? Brightness is actually nothing but the wavelength. ये आप देख रहे हो wavelength. You're able to see how the wavelength has a little bit of an amplitude, the length of the wave, right? That is actually the intensity of the light as well, and that is actually your brightness as well. आप देखो. If something is intensely filled with light, then it is bright. And if it is more towards black or dark or dull, then it is not bright at all. And then the intensity of the color is low. Alright? Perceived intensity of light. आप कितना intense light को perceive करते हैं. So it's going to be a bright color. Right? It's going to be very bright and full of light to the eyes. जितनी कम light, उतनी कम brightness. You must have seen this while editing pictures as well. I'm sure a lot of you edit your pictures on your phone and stuff like that. White has the highest degree of brightness, where black has the lowest degree. They can ask you questions on this. This is very, very important, so please make a note. All right. White will be brightest, and then obviously anything dark or black is going to be what? Very, very low in brightness, almost 0% in brightness. तो ये आपके तीन प्रॉपर्टीज हैं. तो हमने आज स्टडी किया ह्यू, सैचुरेशन और ब्राइटनेस को भी. If we are good to go, we will move on to the theories. Now you may be wondering कि हम कलर कैसे एक्चुअली परसीव करते हैं और कौन सा कलर हम परसीव करते हैं. There might be a misconception about us absorbing colors and those colors being perceived. We actually perceive the color we reflect. Okay? हम कौन सा कलर परसीव करते हैं? जो हम रिफ्लेक्ट कर पाए या जो हम रिफ्लेक्ट करें, जो हमारी आंखें एक्चुअली रिफ्लेक्ट करें. I will give you an example. When you go into a dark room, what do you actually do? Your cones are active and therefore you absorb all the colors that are there. What do you see? जब आप सारे color absorb करते हो तो आप actually black color देखते हो. And जब आप कोई color absorb नहीं करते तब आप white color देखते हो. So if I am absorbing up to here and I reflect green, अगर मैं reflect करूं green, then I will see green. Alright, up to whatever is absorbed is taken in, whatever is reflected from the eye is what is perceived as the color. Absolutely, very, very important to remember. Very, very important to remember. Chaliye. The first theory that we're going to talk about, before that, I want to let you know that I am the top educator for psychology on Unacademy, for NTA UGC-NET, for GATE psychology and all of that. In fact, many toppers have been there from my batches itself. मेरे ही batches से काफी toppers रहे हैं last 2-3 exams में. तो आप, if you want to, you can go ahead and join my classes on Unacademy. Currently, we are providing a 20% off until the 30th of September. आप मेरा code use कर सकते हैं, Hafsa Live. This will give you a 20% off, or you can also use my code HAF10. All good, both will give you a 20% off if you do want to go ahead and subscribe. अगर आप मेरे classes join करना चाहते हैं. Here you go. You have plus as well as iconic. It's totally up to you. Now let's get theories of color vision. क्या हैं? So theories of color vision will help us understand why it is that we perceive certain colors and the addition or the subtraction of what helps us perceive what. This theory by Thomas Young initially in 1802. आप सोचो ये कितनी पुरानी theory है. A very, very, very old theory known as the trichromatic theory of vision. Can I say trichromatic because we have 3 types of cones? क्या हम ऐसा कह सकते हैं कि trichromatic क्योंकि हमारे पास 3 cones हैं जो 3 colors को correspond करते हैं और therefore हम 3 colors perceive कर पाते हैं किसी भी time पे. So people are going to be monochromats, complete color blindness, dichromats or trichromats. Okay, monochromats can only see black and white. Dichromats will either not be able to see red, green, or red, blue or something like that. Whereas trichromatic people or trichromats can perceive all green, red and blue as well. That means कि इनके तीनों cones function करते हैं. इनके small wavelength cones भी, medium wavelength cones भी और large wavelength cones भी तीनों काम करते हैं. And therefore the theory of trichromatic vision. ठीक है? Okay. All right. Absolutely. तो trichromatic vision हम इसको कहते हैं. Now, young Helmholtz और Young ने ये theory दी है 1802 में. फिर 1852 में Hermann von Helmholtz actually modified it. इन्होंने इसको theory को upgrade किया. So the date of the theory that we give the young Helmholtz theory is 1852. Still very, very old. Much more than a century old. काफी पुरानी theory है. Okay. तो यहाँ पे भी हम यही कहेंगे कि color का जो perception है, it is additive in nature. जो color है हमारा additive in nature. That means we just combine one color with another and that is how we perceive. This theory says that all of our cones or all of our small wavelength, large wavelength and medium wavelength cones are excited to different degrees by a certain light. That is how we are going to perceive pink. You see, now for pink, what all has to be excited? Red as well as blue has to be excited, है ना? यहाँ पे ये थ्योरी कहती है कि कलर एडिटिव है नेचर में, मतलब हम एक कलर को कंबाइन करके दूसरे कलर के साथ फिर तीसरा कलर और एक परसीव करते हैं, क्योंकि हमारे बेसिक प्राइमरी कलर्स यहाँ पे क्या हैं? सिर्फ रेड, ब्लू और ग्रीन. ओके, ये आपको रिमेंबर करना है. Red, blue and green only. And can I say all other colors here are simply a combination of these three colors? क्या हम ऐसा कह सकते हैं कि जो भी दूसरे कलर हैं वो सिर्फ इन्हीं तीनों कलर्स का कॉम्बिनेशन हम बनाते हैं? Okay. So again, another very very important point is any wavelength or any color excites the three cones to varying degrees. To varying degrees. Therefore थोड़ा थोड़ा हम ब्लू देखते हैं, थोड़ा ग्रीन देखते हैं, थोड़ा येलो देखते हैं, थोड़ा रेड देखते हैं. Therefore what happens is we end up perceiving different colors. ये देखो आप, this is your cyan, this is pink and this is yellow and white and so on. And therefore इन्हीं की combination होती है जो भी सारे colors हम देखते हैं. Okay, all right, fine. And that is actually about it. ये देखो आप. And therefore the kind of activity that takes place in all three different cones to varying degrees. मतलब हमने red ज़्यादा excite किया है, तो then it will be more of red. It will be reddish something, right? You see a mix of red and blue, then maybe it will be pink. Maybe if it's red and green, then you will see yellow. If it is more on the red side, then maybe you see orange. So depending on the degree of excitement on each of these three cones is how we are going to perceive color. जितनी एक्साइटमेंट, तो यहाँ पे मैं हिंदी में रिपीट करती हूँ आपके लिए. यहाँ पे जो भी वेवलेंथ हम लाइट का परसीव करें या जो भी वेवलेंथ लाइट हमारी आंखों पे प्रोजेक्ट होता है, वो हमारे तीनों कोनों को अलग अलग तरीके से एक्साइट करता है, अलग अलग मात्रा में, अलग अलग क्वांटिटी में एक्साइट करता है. उससे क्या होता है, जो कलर होता है वो वैसे ही दिखेगा. अगर ज्यादा रेड है और थोड़ा सा ग्रीन है तो येलो नहीं ऑरेंज दिखेगा. ठीक है, यहाँ पे दैट इज व्हाट दे आर सेइंग. So it's like that. All right. So that is how we are going to perceive color as well. यही हमारे color perception में करें. यही हमारा color perception define करें. All right. हाँ जी. If we have any doubts here, please let me know. Otherwise, we are good to go. Clear. Okay, let's. चलो. Dichromatic, for them only two cones will be working efficiently. Okay, that is a typical colorblind person, क्योंकि ज्यादातर complete color blindness नहीं होती है. This is common in colorblind people. Sometimes they don't see red, or sometimes they are not correctly able to distinguish between red and green. Not all dichromats are the same. It just means that two of their cones, two types of cones, are functioning properly. Okay? And one of the cones is not functioning properly. Which one it is going to be? That's not always the same. Although red-green color blindness is more common. Deuteranopia, protanopia, and this and that. You can look it up. If you don't find it, you can get back to me. चलिए, ठीक है. Now, although this theory did give us some information about how colors are perceived, देखिए, ऑब्वियसली ये थ्योरी हमें काफी इंफॉर्मेशन देती है इसके बारे में कि कलर्स को परसीव कैसे किया जाता है. लेकिन अगर हमें समझना है कि आफ्टर इमेजेस क्यों क्रिएट होती हैं और आफ्टर इमेजेस कैसे क्रिएट होती हैं, तो फिर व्हाइट एंड ब्लैक का परसेप्शन क्यों होता है और कैसे होता है, वो समझने के लिए हमें दूसरी थ्योरी स्टडी करनी पड़ेगी, जो है आपकी ओपोनेंट प्रोसेस थ्योरी ऑफ विजन बाय इवॉल्ड हेरिंग. ठीक है, इवॉल्ड हेरिंग की ओपोनेंट प्रोसेस थ्योरी. अब इन्होंने क्या किया, इन्होंने ये नहीं कहा कि हेल्महोल्ट्ज थ्योरी गलत है. This theory does not actually mean to oppose the other theory. Both of these theories have actually been found to be correct in varying degrees. Okay, both of them have applications, so one doesn't actually disprove another. In fact, they can both be used together to understand color perception. अब यहाँ पे इन्होंने 4 opposing pairs create किए. What did he create? He created 4 pairs of opposing colors. And what were these pairs? So he created blue and yellow, okay, red and green, not 4, actually only 3. What am I saying? 4, not 3. Okay, 3 opposing pairs of colors. So there is black and white, red and green, and blue and yellow. Rather than having 3 chromatic colors like we did in the previous theory, यहाँ पे कितने chromatic colors हैं? यहाँ पे हमारे पास 4 chromatic colors हैं. And though achromatic colors हैं. We have 4 chromatic colors and we have 2 achromatic colors. Yes? Okay. Absolutely. Absolutely. So black and white becomes one opposing pair here. Red and green one and blue and yellow the third one. Now here he says कि जब आप दोनों में से एक कलर परसीव करते हैं, आप दूसरा सेम टाइम पे परसीव नहीं करते. In the sense he says that there is no combination of these two colors. Like there is no reddish green. Don't say you get brown when you mix them. He's not talking about. He is saying that there is no reddish green and there is no bluish yellow. You either get a new color when you combine these two. There isn't the individuality of both of these is not going to be perceived at the same time. And it's very, very difficult to picture and also perceive red and green together. In the same way, yellow or blue, right? If you mix them, yes, you may get green. But together, is there going to be a yellowish blue? I don't think so. Is there going to be a bluish yellow? I don't think so. There is a greenish yellow and so on. ऐसे ही whitish black नहीं होता है. Gray may be the utter mixture of the dissolution of both of them. But there is no whitish black and there is no blackish white. Right? Like that. And he also spoke about after images. अगर आप इन ऑपोजिंग पेयर्स में से एक कलर में ज्यादा टाइम तक या थोड़ी देर तक कॉन्सेंट्रेट करें, फोकस करें, इनफैक्ट ही इवन हैड एन आफ्टर इमेज एक्सरसाइज. अगर आप कंप्लीटली एक पे फोकस करें तो क्या होता है, इमीडिएटली व्हेन यू लुक अवे ऑन अ प्लेन व्हाइट सरफेस यू सी द ऑपोजिट कलर. मतलब अगर आप ब्लैक, रेड और ब्लू एक इमेज देखेंगे, ठीक है, black, red, blue, if you see, what will you see in the after image? आप आफ्टर इमेज में व्हाइट, ग्रीन और येलो देखेंगे. ये 3 कलर्स कंबाइंड आप देखेंगे. इन द सेंस कंबाइंड, आई मीन यू विल बी एबल टू पिक्चर देम वन बाय वन. एंड ये completely, the after image is completely explained by the opponent process theory of vision. ठीक है, तो आफ्टर इमेजेस जो है हमारी वो क्यों अकर करती हैं? बिकॉज वी एक्चुअली परसीव फॉर अ लॉन्ग टाइम, और वी लुक at the opposing pair or the opposing color for a long time. And जब हम एक white sheet पे उसके बाद देखते हैं तो हम opposing colors देखते हैं. Immediately after हम ये color जिसकी तरफ हम देख रहे थे वो नहीं देखते हैं. Okay, all right, absolutely. Thank you so much, Sachin. Absolutely. That is because here one color inhibits the perception of another color. यहाँ पे दोनों एक साथ क्यों नहीं परसीव किए जाते, या उनकी उनके डाइल्यू या मिक्सचर्स क्यों नहीं हम देखते, रेडिश ग्रीन क्यों नहीं देखते? क्योंकि एक कलर यहाँ पे दूसरे कलर के परसेप्शन को इनहिबिट करता है. दैट इज व्हाई दे आर ऑपोजिट पेयर्स और ऑपोजिंग पेयर्स. दे डू नॉट अकर टुगेदर. Okay, that's basically it. You ought to remember the names of the opposing pairs. आपको opposing pairs के नाम याद रखने हैं, और आपको ये भी याद रखना है कि after image किस color की आएगी. Obviously, it will be the other color in the opposite pair, right? Result of okay, all right. Why does this happen? It is due to the result of an activity of the region, particular region of thalamus that receives visual information, which is the lateral geniculate nucleus, as we have already seen. And tell me which is going to be most interested in color vision, particularly the parvocellular system or the magnocellular system. Do you guys still remember? Tell me if you still remember. Do we still remember? Color vision में ज़्यादा involved कौन होगा? Nothing. Okay, I will wait. I will just wait. Parvocellular system, correct. Absolutely, which is present in the lateral geniculate nucleus of the thalamus. So if you are asked what part is stimulated when we perceive after images, you can just say the lateral geniculate nucleus of the thalamus. That's about it. That is it for this theory. We will just do a little bit of dark adaptation, light adaptation. Uske baad we are good to go. Let me know if you've understood. Let me know if you've understood whatever I have explained. Don't know, ma'am. We have done it in class, Sani. Why are you not revising? Please go revise. क्लास में कराया है आप. चलिए. All right. So here I have linked opposing pairs for you as well. After image कैसी आएगी? ठीक है? After image कैसी आएगी यहाँ पे? You can take a screenshot. हाँ, you can take a screenshot if you want. चलो ठीक है. Let's go. Now let's compare the two theories quick so that we can move on to the other concept that we're going to discuss today. Trichromatic theory जो है वो कहती है कि आपके receptors लेते हैं light information लेते हैं. There are trichromatic theory of vision basically says there are receptors, photoreceptors, cone cells mostly if we're talking about color. Then they take in light and they do some sort of color matching because every single wavelength excites all three cones टू वेरिंग डिग्रीज. मतलब अलग अलग डिग्री में आपके सारे कोन एक्साइट होते हैं. किस बेसिस पे? जब लाइट इंफॉर्मेशन एंटर करती है तो वो आपके सारे कोन्स को अलग अलग तरह से अलग अलग डिग्रीज में एक्साइट करता है और इस वजह से हम कलर मिक्स एंड मैच करते हैं, कंबाइन करते हैं, एडिटिव, राइट. हम ऐड करते हैं कलर्स को और हम परसीव करते हैं. नाउ वी क्लियरली मस्ट रिमेंबर दैट लाइट इज जस्ट द sensation, whereas perception is of color, right? And sensation is never equal to perception. Opponent process theory says that there are opposing cells, opponent cells, right? क्या होता है? Because of simultaneous contrast, very very important word here. क्योंकि simultaneous contrast perceive करने से one color inhibits the perception of another and therefore we see after images and therefore we are only able to see one of the two opposing pairs at a single time, or we are only able to focus on one of the opposing pairs at a single time. All right. And according to the opponent process theory, this is how information goes to the ठीक है. Ma'am, in all day, whatever color we see, which theory explains this? I think I said both. Both theories are theories of color. You don't only see colors during the day. You also see colors during the night when you have lights on in your room. Rod cells are only for night vision. By night vision, we don't mean कि 7 o'clock हो गया, but lights are on in your house and rods are active. No. Rods are active when you turn off all of your lights. जब आप lights off कर देते हैं room में, तब आपकी rod cells active होती हैं. Color perception जो भी है वो आपके cones ही करते हैं. Okay. Now, do we know that we have a duplicity theory of vision? या हमारा vision जो है वो दो तरह का होता है. A separate one for when light is present and a separate one for when no light is present. Yes? Okay? All right. Absolutely. Absolutely. So here we need to understand कि दिन में कैसा vision होता है या bright light में क्या vision होता है and what do we do in light and dark adaptation. Just a little bit of an overview and then we're good to go. Now, what happens to the pupil size? What happens to our eyes? What happens to our rods? And what happens to our cones? So, I'm simply going to write night vision and day vision or color vision, color or day, achromatic or night vision. Okay? All right. Now, let's first talk about pupil size. देखिए, light adaptation या जब हम काफी light perceive करना चाहते हैं. First of all, let's talk about what is light or dark adaptation. Dark adaptation happens when we go from a very bright place to suddenly a dark place. Is that correct? डार्क अडेप्टेशन तब होता है जब आप ब्राइट एनवायरनमेंट में से जैसे थिएटर में चले जाते हो तो रूम में बिल्कुल अंधेरा होता है, तो हमें डार्कनेस को अडेप्ट करना पड़ता है. करेक्ट और नॉट करेक्ट? यस, फ्रॉम लाइट टू डार्कनेस, है ना? And color or day vision or light adaptation is going to happen when you step back out from that theater, because आप सारा दिन theater में तो रहेंगे नहीं, वापस तो आना है. So you will get out of the theater, and the moment you get out, you're like, oh my god, too bright, I can't take it. That is from darkness to light. Hmm? Light adaptation. Okay, wonderful, great. हाँ जी. Pupil size का क्या होगा? When you get into a dark room, do you need more light to enter your eyes for you to see anything? होता क्या है actually, when you suddenly go into a dark room, your cone cells are active. And cones आपके darkness में नहीं देख सकते क्योंकि वो light perceive करते हैं. तो in the absence of light, what are they going to do? Your rod cells have to be regenerated. Therefore, the eyes open wide and try to take in as much light as possible. तो dark adaptation में आपकी आंखें या आपके pupils dilate होते हैं. Okay, dark adaptation indicates that the pupil is going to dilate. And what about when we go from a dark room to a bright atmosphere? जब हम पूरी bright atmosphere में चले जाते हैं तब क्या होता है? Our rod cells are active and they cannot stand too much light. It's too much for them. They get bleached and the cone cells come forward. Then what do we need? Do we need a lot of, space for a lot of light to enter? हमें क्लियर इमेज दिखेगी क्योंकि लाइट काफी सारी है एनवायरनमेंट में, तो हमें प्यूपिल को डायलेट करने की जरूरत नहीं है. इनफैक्ट वी वांट टू लिमिट द अमाउंट ऑफ लाइट दैट्स एंटरिंग बिकॉज देयर इज टू मच लाइट. So therefore we will constrict the pupil. All right, okay, wonderful. Then what else happens? Now we know that in achromatic या night या dark adaptation, who is supposed to be more, what do I say, active? Rods को regenerate करना पड़ेगा ना? Rods are regenerated. Okay? And here rods are bleached and cones are brought back. Not rods, rods. Actually write it within. Rod cells are bleached, destroyed, and cones take up function. Very, very good. Very, very good. Okay, this is also done. This is also done. Feedback from horizontal cells to control. So you have horizontal cells and you have circular cells. All right, जो control करती हैं. What is going to happen over here then? Are we going to be more sensitive towards light when our rod cells are actually in function? जब हमारी rod cells पूरी function करती हैं, क्या हम ज़्यादा sensitive होंगे light की तरफ? Rod cells are more sensitive to light. Therefore, higher sensitivity to light will be present in night vision. Okay, and here cones are actually not as sensitive as rod cells. All right. So we say high intensity light but low sensitivity light. The last thing that I want to discuss with all of you is night or dark adaptation actually takes longer. Dark adaptation proper करने में ज़्यादा time लगता है क्योंकि rods को regenerate करना पड़ता है. They are bleached during the day. And each time you move into a dark place, takes a lot of time or it takes some time for your eyes to adjust because rods take some time to regenerate, or it takes time to regenerate rods. That's all. Takes more time. In case you're asked in the exam. And since cones are already there, they are not bleached, they just have to start functioning, takes lesser time. Okay, all right. That is about it. Absolutely, Sachin. That is about it for today. I hope you learned something. I had a great time talking to all of you. I hope you all have a great day ahead. If you did like the class or if you like my classes, Please share, please subscribe to support the channel. Please join the group if you would like to see more of my classes. And that is about it. All right. Have a great Monday. I'll see you tomorrow. Tomorrow we will do perception of audition or hearing ke theories, and that'll be really fun as well. I will also explain the structure of the ear to you once again. It's very, very important to understand the perception. So I'll see you here at 11 a.m. tomorrow. Have a great day. Bye bye.